Logarithmic and exponential equations, I'm going to set up two scenarios for each and show you how to solve each one, and I hope by the end. I think the exponential is probably the hardest, the exponential with two exponential pieces, because there might be some base manipulation, like we remember when we did the manipulating of the bases to make them the same. Same kind of thing here. All right, so let's look, first off, the first scenario I'm going to look at is if we have one exponential term and how to solve that. And so what I mean by that is something that looks like 4 to the x equals 11. Okay? There's only one term that has the exponent with the variable hooked to it, one exponential term. Okay? So what I want to do is I want to make sure that the exponential piece is isolated. Isolated? 4 to the x? Oh, yeah. Oh, my goodness. Okay, so the variable is in the exponent. My question now is, how do you find out what x equals? What can you do? Well, you can't, if you root it, you would have to x root it, and then that doesn't help you in solving. Come on, y'all. What have we been? Exactly. What's the inverse of exponential? Logarithmic. We're using we're using inverses to solve. So change the form. If you change the form, the answer will pop out at you. What is this? This is exponential form. What is it in logarithmic form? Log of 11 equals x. So now I need a value for log base 4 of 11. To find the value of log base 4 of 11, yes, you do, Lizzie. Good job. You do log 11 divided by 1.73 is approximately what my x is. I'm more worried about your process here in getting there than I am that. Unless it's indicated. Let's try another. I want you to try this one, see what happens. Remember, isolate it, change the form, and finish solving. This is not step one, that's just scenario. Alright, here's another example. 4e to the negative 0.3x minus 7 equals 13. Good job, Colin. There's a button on your calculator. And so you use it the same way you log. Yes, Olivia. Well, after you add the 7. Yes, you do. Did y'all hear the question? Because we have to isolate that exponential piece. And divide by 4. So is the exponential piece now isolated? Alright, is it what now? Okay, log base e is the same thing as natural log, right? So it's natural log of 5 equals, logs always equal exponents, negative 0.3x. Yes, Justin. Yes. Yeah, you still. Alright, so this is coming back to changing forms. Remember, logs always equal exponents. So it's going to be log, the base is e, of 5 equals whatever that exponent is. And I just changed log base e to ln. Okay? Y'all with me? It seems like we're struggling with changing forms more than anything else.
Changing form.
What's that show? The Middle, where the brick, and you always like. Okay, I'm gonna divide by negative 0.3. So I'm gonna use my calculator on this one.
What's your calculator?
See if anybody actually goes back and watches the video. Alright, so natural log of 5 divided by negative 0.3, negative 5.36. You want me to go back? You want to see the calculator? Record again. This is probably the hardest of the 4 scenarios we're going to do today. It's 2 exponential terms. And I think the reason that it seems the hardest is because you do have to do some manipulation of it. Just as a reminder, if I have 5 to the x equals 5 to the third. This is second, 2 exponential terms. Okay. If I have this, x equals 3, because if the bases are the same, then I set the exponents equal, right? So that's kind of what we're going for here. So, for example, if I have 9 to the 2x equals 27 to the x minus 1. Okay? For these, you have to get them separated and then force the bases to be the same. Now, the hardest part about this is that the value itself cannot change. In other words, the base has to still be 9, even if you rewrite. So I could rewrite that as 3 to the second power, but 3 to the second power is still 9, right? Okay, so it's got to still have the same value at the end of the day. Can't change that. And then we'll set the exponents equal. So I kind of just gave it away. Separate. That's the first thing. Separate the 2 exponential terms, separate them, force the same bases, and then set the exponents equal to solve. Okay? It doesn't matter. Mom, you cannot text during class. Yes. 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 This is second scenario. There's 4 scenarios. There's 4 scenarios. This is scenario number 2. Okay. 2 exponential and 2 logarithmic scenarios. All right. There's 4 topics I'm taking you through. How about that? This is topic number 2. All right. Hey, I thought I separated y'all. All right. I'm going to manipulate these to have the same base. I'll deal with that in just a second. Each other. What can you change this to have a base of 3? Exactly. Good job, Lizzie. You're on it today. 3 to the second. Now the 2x is still here. And 3 to the third. And we're gonna make it harder, of course, in just a minute. You can't do this because you haven't written anything yet. All right, do we agree the bases are the same now? Exponents equal to each other. That was a statement. 2 times 2x equals 3 times x minus 1. Again, guys. All right, so now, yes, I'm multiplying them. If you multiplied them before you took them, like if you changed this to 3 to the 4x equals 3 to the 3x minus 3, and then set them equal. That's fine also. So now I have 3x minus 3. Solve it. How do you solve it? Which is like terms. You're right. You're both right, yes. So x equals negative 3. Easy enough? Not basically, that is what we're doing. The directions say solve. Yes. All right, let me show you. Yes. Let me show you this one. This is where it really starts getting a little... I have two exponential terms, the two of which are already separated, right? I have to find some way to force the same space. Now, at the end of the day, the left side has to be 4 and the right side has to be half. Somebody said 2. But you could use 4 also, Drew. You're not wrong. Somebody, hold on. Drew, I raised his hand. Let me let you. You can't use negative 2 because that wouldn't... It's still got to have the value of 1/2. Like, you can't just put a negative 2 on a half and say that equals 4, because while it does, it's got to, at the end of the day, it's got to equal a half. Like, yes, this is a true statement. That's true. But if I just throw a negative 2 exponent on a 1/2 base, you're trying to make the bases be the same, right? True. No, I thought you had it. I thought I heard you say something. Ooh. Well, but then you're going to have to... What? Yes. Yes. Good job, Drew. Is the base still 4? Is that value still 4? What's in parentheses? Okay. Actually, sorry. Yes. Is what's in parentheses still 1/2? Yes. Right? The value is still the same. That's the key to this. The value has to be the same. You want to write it a different way, but the value must remain the same. So y'all were having good ideas, but it was changing the value at the end of the day. So you have to keep the value. All right, so now I can... All right, look. This still had to be 4. Right? Which part? Because I've only done one step. No, I'm not trying. I wasn't trying to be nasty here. It's the heat. Okay, Cullen. I have to force these to be the same. What I noticed about them is they're both powers of 2. Okay? Mind you, this might be a negative power of 2, but it's still a power of 2. So I have to change it. So I changed 1/2 to 2 to the negative 1. I changed 4 to 2 squared. Now I can set the exponents equal to each other. Okay? 2x equals negative 1 x minus 3. No, we need to quit worrying about the smell and worry about the math. Say that again. Because this is going to have to distribute to everything out here. Because it's a power to a power, so it multiplies. Where did what? I dropped the base of 2's and just set the exponents equal. Once you force the same base, they go away and get. No, what? Oh, yes. I didn't see the negative there. I think we need to do one more of these questions. Y'all ain't got up. I think, though, after you get one and you see the pattern, it's not quite as hard. I'll do one from your homework. This is number 11 on your homework. Tell me when you got it. This is number 11. Don't blurt it out when you figure it out. Yes. 5 to the what? Second. And 5 to the negative 3. So 10x plus 8. I should have picked like a quadratic formula. Oh, thank you, Avery. I sure didn't. All right, 20x plus 16 equals negative 12 plus 6x. I'm going to move the 6x over and the 16. Right here, Cullen. Scenario 3. We're going to talk about, I guess there is 3 scenarios with logs. I do apologize. 1 log, 2 logs, 2 or more logs. All right. 1 log is the easiest. You'll see. You're going to isolate the log. Somebody said we're going to do it just like exponentials, and yes, we are. We're going to isolate the log and change the form to solve. Because logs and exponents go hand in hand. Oh, gosh, Stacy. I'm saying exponents. I meant to say, yes. Exponents? All right, so for example, log base 4 of 5x minus 1 equals 3. Is the log isolated? Yes. What's in parentheses that follows the log, that's like the a part of the log. Okay, so that doesn't move. Now, if I had plus 1 out here, outside the parentheses, yeah, I need to take care of that first. But what's in parentheses there stays with the log. All right, change the form. 4. Right? So I have 64. Go ahead, Isis. What were you about to say? Add the 1. Justin. I changed it to exponential form. Base, so it's, and look, if the log is on the left side, this is a little cutesy thing. If the log is on the left side, the way you change forms from logarithmic to exponential makes an E. Watch. B to the x equals A. B to the x equals A. It looks like a big E. But changing forms, remember I told you at the beginning, it's all going to come back to being able to change forms. All right. Exactly 2 logs, nothing else. Nothing else, just 2 logs, and those 2 logs must have the same base. Okay? For example, log base 5, 4x minus 7 equals log base 5, x plus 5. Yes. Okay, I'm not going to spend any longer than that on this because it's that easy. You get them on both sides of the equal sign. Subtract the x. Add the 7. And divide by 30. The final scenario is the most fun scenario. C. I thought I'd just stand up here and scenario 5. The final. I lied. The other stuff is probably going to be something like a plus 2 or minus 2, plus 4, something of the sort. Okay, it's not going to be anything too complicated. But here's what happens. Let's say I have log 2x. These are my favorite. Log x minus 5 equals 2. So when it's like this, we need the logs together. Now, and they are. Now my question to you is, can you think, I can't change the form the way it is yet. First of all, let's do it. Good job. Wow, I'm impressed. All right, so we have to condense the logs. If I condense the logs on the left side, just as though because we're adding, that means we multiply, and that is exactly right. So I have log of 2x times x minus 5. And all that goes with the log, and it equals 2. Right? So that becomes log of 2x squared minus 10x. Are we all in the same boat? I'm back to scenario number 3. What does it look like in exponential form? 10 squared. Holy potatoes, what do I have here? It looks like a quadratic. 100 equals 2x squared minus 10x. Because it's a quadratic, I need to make it equal. Yay! What? You could, but I've got a feeling this is going to factor out for us. The first thing I'm going to do, or maybe not, I don't know, we'll have to see. First thing I'm going to do is figure out the PCF. 2, Owen's fixing to fall asleep. You can join Evan for nap time, apparently. Oh! Multiplies to negative 10, adds to negative 5. Oh, because I'm an idiot. I thought it was going to factor. Now it'll factor. Negative 10 and positive 5. Don't pay. Nobody's listening to him. Okay? We're trying to hit 10. 2 more times. Don't worry. I was going to say, if you just wait long enough, you're going to do it to yourself. All right. Here are my two solutions.